Hello everyone, welcome to Geeky Nerd. Today we will begin with the part 6 video of the aptitude topic time, speed and distance. This will be the final video of this aptitude topic. Before moving into the video, I hope everyone would have become thorough with the previous videos related to this topic. If you have not seen them, click on the card or the links in the bio. In this video, we will deal with two of the most important concepts, that is early or late concept and chasing. Like, share and subscribe the channel for more interesting concepts and shortcut methods for solving them. So without wasting any time, let's head into the video. So the first concept which we are going to see today is late or early concept. So this question is most familiar and would occur at least 5 out of 10 times in any of the aptitude examinations under the topic of time, speed and distance. So the statement says that if the new speed is a by b times of the original speed, then the change in time del t to cover the same distance is given by. For example, this question would go like this. A man would travel a by b times of the original speed and he would reach the destination few minutes or few hours late or early. In such cases, had he travelled by the original distance, what would have been the original time required to reach the destination? In such cases, we can compute either the time which is getting delayed or becoming early because of the new speed, as well as the original time using the formula change in time del t is equal to b by a minus 1 into time. We know that in the question speed is given as a by b and hence speed is inversely proportional to time. Therefore, in the solution formula, we use b by a instead of a by b. Therefore, changing time del t is equal to b by a minus 1 of original time. Here, the value of del t will bear a positive value if the time is getting delayed because of the change in speed, and it will bear a negative value if the person reaches the destination earlier because of the change in speed. Let us solve some examples to understand how this works out. Walking 6 by 5th of his usual speed, Mike reached his destination 10 minutes early. Find his usual time. So from the question, it is given that new speed is equal to 6 by 5 times of usual speed. When he travels like this, change in time, that is del t, is equal to 10 minutes, which is equal to 1 by 6 if you convert it into a hour. So from the question we need to find what is the usual time. We know that when the speed becomes a by b times of the original speed, and if he manages to reach the destination del t time early or late, then the changing time del t is equal to b by a minus 1 multiplied by original time. Here we need to use minus del t because early. In case had he reached his destination late because of the change in speed, then del t would have been plus. Substituting the known value, we get minus 10, that is 1 by 6 in terms of hour, is equal to b by a. In the question it would have been written as a by b. Therefore reciprocating we get 5 by 6 minus 1 multiplied by original time, which we need to find. which implies original time is equal to minus 1 by 6 multiplied by minus 6 by 1, which in turn will give the answer as 1 hour. Therefore, when Mike changed his usual speed to 6/5 of his usual speed, then he reached the destination 10 minutes early. Thus, the usual time at which he traveled is equal to 1 hour. From the question, we can easily identify that he has changed his speed with 6 by 5 times of the original speed or the usual speed in order to reach 10 minutes early. Therefore, new speed is equal to 6 by 5 times of usual speed, that is A by B is equal to 6 by 5. We know that change in time is equal to 10 minutes. As he reached 10 minutes early, the change in time would become negative. Therefore, when 10 minutes is expressed in hours, it is called as 1 by 6. Therefore, minus of 1 by 6 is equal to, in the question, speed would have been given as A by B, but while substituting in the formula, we have to reciprocate it as B by A. Therefore, 6 by 5 becomes 5 by 6. That is minus 1 by 6 is equal to minus 1 by 6 is equal to 5 by 6 minus 1 of original time. Upon solving, we get the usual time at which Mike travels as 1 hour. Let us solve one more example based on this concept. Moving 6 by 7 of its usual speed, a train is 10 minutes late. So it is given that new speed is equal to 6 by 7 of original speed. When it happens, the train reaches 10 minutes late. Therefore, change in time del t is equal to 10 minutes, which is equal to 1/6 of the hour. So here, change in time will be considered as positive because of delay. Positive because of late. We know the formula that change in time del t is equal to b by a minus 1 of original time. Therefore, 1 by 6, writing 10 minutes in terms of hours and then changing it as 7 by 6 minus 1 of original time, which implies original time is equal to 1 by 6 multiplied by 6 by 1, which is equal to 1 hour. Thus, the train usually moves at 1 hour, and when it travels at a speed of 6 by 7 times of the usual speed, it reaches 10 minutes late. So whenever change in time is given and usual time is asked to be found out, we can use the formula change in time del t is equal to b by a minus 1 of original time, where b by a is the reciprocal of the change in speed a by b, and del t will be positive if the object reaches the destination late, and del t will be negative if the object reaches the destination early. So let us move on to the next concept. Distance between two places based on late or early concept. So just now we discussed about early or late concept, and the new concept is an extension of it. So the statement reads as if When a person covers a certain distance between two certain places with speed s1, he gets his destination late or early by time t1, but when he covers the same distance with speed s2, he reaches his destination t2 time earlier or later. So it is being stated that a person is covering a certain distance with speed s1 such that he reaches late or early, and when he reaches the same destination with speed s2, he might return early or late. In such cases, the distance between the two places can be determined using the formula distance is equal to del t multiplied by speed of first journey multiplied by speed of second journey, the whole divided by s1 difference s2. Here s1 difference s2 indicates whichever speed is larger that can be subtracted or used as the first quantity in the denominator, whereas del t refers to addition of the time taken of the two journeys if the two concept has a mixture of early late or late early. In case if both the journeys result in same result, that is early early or late late, then the two time taken will be subtracted. Thus we can find out the distance between the two places as del t multiplied by s1 multiplied by s2, the whole divided by s1 difference s2. A boy walking at a speed of 15 km per hour reaches his school 20 minutes late. Next time he increases his speed by 5 km per hour, but still he gets late by 5 minutes. Find the distance of the school from his home. So it is given that S1 is equal to 15 km per hour, S2 is equal to 15 plus 5, that is 20 km per hour. So it is given that T1 is equal to 20 minutes late and T2 is equal to 5 minutes late. So in such cases, we need to find the distance between the two places, that is school and home. Since T1 and T2 both occurs as late, del T is equal to T1 minus T2, which is equal to 15 minutes, which is equal to 1 by 4th of the hour. Thus, having seen in the concept, we know that distance between school and home is equal to del T multiplied by S1 multiplied by S2 divided by S1 difference S2. In our case, S2 is greater than S1, therefore 1 by 4 multiplied by 15 multiplied by 20, the whole divided by 20 minus 15. So this in turn will give 75 by 5, which is equal to 15 kilometers. Therefore, the distance between the school and home is equal to 15 kilometers. Let us solve one more example to understand this concept clearly. If Sohail walks from his home to office at 16 km per hour, he is late by 5 minutes. If he walks at 20 km per hour, he reaches 10 minutes before the office time. Find the distance of his office from school. So it is given that S1 is equal to 16 km per hour and S2 is equal to 20 km per hour. It is also given that T1 is equal to 5 minutes late and T2 is equal to 10 minutes early. Therefore, T1 and T2 occurs as late and early. Henceforth, change in time del T is equal to T1 plus T2, which is equal to 15 minutes, which is equal to 1 by 4 in terms of hour. Thus, from the concept we understood that distance between office and home is equal to del T multiplied by S1 by multiplied by S1 multiplied by S2, the whole divided by S1 difference S2. Here del T is equal to 1 by 4 multiplied by S1 16 multiplied by S2 20, the whole divided by 20 minus 16, which is equal to 80 by 4, which is equal to 20 kilometer. Thus, the distance between the two places using early or late concept is one of the most important subtopics related to time, speed and distance. Hope everyone would have understood. Now we will see another concept which is also an extension of the concept which we dealt right now. A policeman sees a thief at a distance of d. He starts chasing the thief who is running at a speed of a and the policeman is chasing with a speed of b. Always b is greater than a. In this case, the distance covered by the thief when he is caught by the policeman is, so this concept is referred to as chasing. It is an extension of the concept what we learned just now. So the concept states that the initial distance between thief and the policeman is d. Let a be the speed of the thief and b be the speed of the policeman. So this concept is about policeman catching the thief. Therefore, it is a must that speed of the policeman should always be greater than speed of the thief, that is b greater than a. In such case, policeman catching the thief is inevitable. We need to find the distance traveled by the policeman to catch the thief. That is, distance traveled by the policeman to catch the thief is equal to del D the whole multiplied by A divided by A difference B, where A refers to the speed of thief, B refers to the speed of policeman. Here, the distance travelled by the policeman to catch the thief is equivalent to the extra distance travelled by thief from the initial stage. Therefore, this or that, the formula remains the same as del D the whole multiplied by A divided by A difference B. Let us solve some examples to understand this. A thief is spotted by a policeman from a distance of 200 meters. When the policeman starts chasing, the thief also starts running. If the speed of the thief be 16 km per hour and that of the policeman be 20 km per hour, how far the thief would have run before he is overtaken? So from the question, it is clear that distance between thief and policeman is equal to 200 meter, which is considered as del D. Speed of thief that is A is equal to 16 km per hour. Speed of policeman B equal to 20 km per hour. We know that the distance traveled by policeman to catch thief is equal to del D the whole multiplied by A difference of A minus B. Here we know that both A and B, that is speeds, are in kilometer per hour and distance is in meter. So for simplification we can convert distance also into kilometer. Therefore substituting the known values we get 0.2 the whole multiplied by 16 by 20 minus 16, which in turn will give zero point 0.2 multiplied by 4, which is equal to zero point 0.8 kilometers. Therefore, the policeman would have run zero point 0.8 kilometers before he caught the thief. Through this video, we learned how the speed varies with respect to time, that is early or late, and chasing. Problems were solved via shortcuts as well as traditional methods. Viewers can choose any method depending upon their convenience. With this video, we have successfully completed the aptitude topic time, speed, and distance. Let's have a quick recap of what we have learned across the 6 parts. In the part 1 video, we discussed about the introduction and the definition of basic terminologies involving time, speed, and distance. We also knew how to convert one unit metric of speed into another. We solved few problems involving the basic formulae of time, speed, and distance. In the part 2 video, we dealt with the relationship between time, speed, and distance. That is, how the two of the three entities are related with each other when the other one remains constant. In the part 3 video, we learnt about average speed. This remains the same as the part 7 video of the aptitude topic averages. In the part 4 video, we learnt a new topic called relative speed. We knew the definition of relative speed, followed by how the speed of one object varies with respect to the direction of another. In the part 5 video, we learnt about three different concepts or applications of time, speed, and distance. That is, the distance traveled by the train, ratio of speeds, and speeds with and without the stoppages. In the last part, we learnt about another application of the basic formulae, that is early or late concept and chasing. Here we learnt how the speed varies with respect to the time. I insist all the listeners to practice solving more and more problems to increase their confidence. Like, share, and subscribe the channel and convey it to your friends so that they can be benefited. Until we meet in the new aptitude topic, thank you.